Okay, fine. So, good. We're still going to stick with drawing graphs, but this time I just want you, just as a thought experiment, can you expand that for me? So can you tell me what we get?
X squared plus 5.
Good. Are we all happy with that? We all happy with that? Because what we've done is skipped a step. X times x, x squared. X times 3 makes 3x. 2 times x makes 2x. There's your 5x, 3x plus 2x. And then 2 times 3 makes your 6. Okay? If you weren't sure about that, you could always use my technique which I showed you earlier. Draw out your graph. Sorry, draw out your square. Or would it be a square in this case?
We can, because it's not the same.
Okay, would it be a square in this case then?
It can be a rectangle.
Good, so it could be a rectangle, right? Okay, it's not very rectangular, but it's a rectangle. Because this has to be different to this. So you're timesing two lengths together which are different, you've got your rectangle, okay? X plus 2, well, okay, let's use this side as x plus 2. That makes sense? And let's use this side as x plus 3. So that's x, and that's 3, okay? Then again, I draw my dotted line across, dotted line down. What's that bit?
X squared.
What's that bit?
6.
6, because it's 2 times 3. What's that bit?
2x.
What's that bit? So if we put it all together, we get x squared, 5 x's, and a 6. Is that okay? So either you can do it just by doing those expanding out, making sure everybody in the first bracket meets everyone in the second bracket, or you can think about it visually like this. Okay? Good. Excellent. So now my question is, where's my rubber? Now my question is, can you take me back? If I gave you this, and I wanted you to get back to this, how would we do that?
Where we get 6 times 1, 3 times 2, and that's it.
Yeah.
Okay.
And we see what's the other number with that. If it matches the, for example, we have 3 times 2. If 3 plus 2 is 5, which means this is correct, and we put the 2 and 3. And since it's 2 positive, we put 2 positive in there.
Absolutely right. So what we're doing is we're thinking about how we got from here to here. Okay? This 6 had to come from multiplying two numbers together which didn't have an x in. And if you look at where we came from, the two numbers which didn't have an x in were the 2 and the 3. Does that make sense? So you're basically saying, I want to make this look something like x plus something and x plus something. So I'm trying to make it look like this, x plus something and x plus something. My question is, what are those two numbers? Okay. Well, if I multiply those two numbers together, I know it has to make 6. It has to make 6. So I'm looking for two numbers which multiply together to make 6. Does that make sense?
1, 6 and 2, 3.
Yeah, exactly. So I'll get there in just a second. But if you also think about it, where did this 5x come from? It came from multiplying the 2 with the x and the 3 with the x. Okay? So in other words, these two numbers have to add to make the 5. Yeah? So they always have to multiply to make this number and add to make this number. Okay? So I can't emphasize that enough. If you get that in your head, you'll be fine with this. Okay? So multiply together to make the last number, add together to make the second number. So let's do this. Let's imagine we didn't know where we came from. So let me get rid of this. Okay, let's think about it. I'd start here. What are the factors of 6? Can you think of two numbers which multiply to make 6?
6 times 1, 3 times 2.
Good, 6 and 1 and 3 and 2. I'd start there, okay? Now let's think about it. I also know they have to add to make positive 5. So does 6 plus 1 make 5?
No.
No, so I can rule those ones out. Does 3 plus 2 make 5? Yeah. So I know those are my two numbers. So I'm going to put a 3 there and a 2 there. Okay? So that's how I get from here to here. Now why is that useful? Well, let's think about it. Let's think about it. What were we just doing? We were sketching graphs, right? So if I said sketch this graph here, okay, I would say, okay, I need a y-intercept. And I'd also need my x-intercepts. So y-intercept, how do we find the y-intercepts again?
X equals 0.
Yeah, good. We set x to be 0. So if we set x to be 0 in here, what do we get? Well, we get y equals 0 squared plus 5 times 0 plus 6 That's 6. Okay, so we know our y-intercept's at 6. X-intercepts, what do we set to be 0? Set y to be 0. Let's do that. So we've got x squared plus 5x plus 6 equals 0. I'm setting the y to be 0, right? And then I'm here, and I'm like, what could I do here? Because this isn't just as simple as the last one. If I gave you x squared plus 5x, it would be easy, right? Now we've got the plus 6, it mucks things up. But you've just seen how we factorize it. You've just seen how we factorize it. We're looking for two numbers that multiply to make 6 and add together to make 5. And then we can put it into two brackets now. Okay, so we start off with x and x. That's how we get our x squared. Number here, two numbers multiply together to make 6, add together to make 5. You told me that was 3 and 2. And you're like, okay, multiplying two numbers together, they make 0. Like number times a number makes 0. At least one of those things has to be 0. So either x plus 3 has to be 0, or x plus 2 has to be 0. So if x plus 3 equals 0, what's x got to be equal to? If x plus 2 equals 0, what's x got to be equal to? Okay, those are my two x-intercepts. Okay, so I've found my x-intercepts, I've found my y-intercepts. I think we're just about in a position to sketch this. Positive or negative? Happy face or sad face? Happy, good. So let's draw that in first. There we go. Okay, let's start with our x-intercepts first. There's my x-axis. What's this point got to be? Good. What's this one going to be? Negative 2. Good. Where's my y-intercept? It's got to be at 6, right? So, okay, 0's here. So if I draw my y-intercept in here, I know that point there has to be up there at 6. Does that make sense to everyone?